Wait, isn't there like 51 of these chunk fights though?
Something like that. Are we going to get through all of them? I don't know. We're just going to keep going though.
Oh, yeah.
Right, for number 1, you need to distribute. So this will be 10x minus 14 plus 3x. And then combine the like terms. So you have 13x minus 14. Questions on number 1. Number 2, is this relation a function?
Yes.
Each x value goes to one y value, so this is a function. For number 3, you need to find the slope. So 4 minus negative 2 over 5 minus negative 1, or you could change those so that it's 4 plus 2 and 5 plus 1 to get 6 over 6, which is 1. Questions on that one? Number 4, you needed to solve. To start off by distributing, you have negative 6x plus 15, minus 15, sorry, plus 4x minus 36 equals 1. Combine your like terms. You have negative 2x minus 51. Add 51 to both sides to get 52 and divide both sides by negative 2 to get negative 26.
Negative.
Yeah, because the 2 is negative. And for the domain and range, those need to start off with curly brackets, x or y with a line. For your domain, that one has a starting place. Caleb, are you going to answer that? It has a starting place, so it can't be all real numbers, and it doesn't keep going in both directions. What was the domain for this one? Yes, so x is greater than or equal to 0. Starts at 0, and then it's everything to the right, so it's everything greater than or equal to 0. For our range, what was that? I mean, not the range. So we would write that y with the e and the r. Questions on that? I did pass out new answer sheets if you're using this. I don't know if you did. Not. I also passed out with that your new set of notes. It should just be one sheet. So we're going to start that here in a second. Yes. I'm going to pull this down so you guys can fill this out first. Then I'm going to talk to it as you're writing it down. So this is the second way to solve systems of equations. We talked about the first way last class. The first way was graphing. The second way is the substitution method. So for the substitution method, this is a method of solving systems of equations by substituting equations within one another. The steps for this are solve one equation for x or y, substitute the equation into the other equation and solve for the variable, substitute your answer, into the revised equation from step 1, and we'll talk about that. That part doesn't really need to happen, and solve for the other variable. So it's a lot of solving, substituting, solving, substituting, solving.
Define substitute.
When you evaluate, you take a number and you put it in for x or y, and then you simplify. Same thing. But now it's going to be equations instead of just a number. Substitute, plug in, those words are synonyms.
I keep spelling substitute wrong.
Okay, it's me all the time. I have to like
This is why I don't use that word.
substitute, do that.
Switch be a better word instead of
Switch might not give you the same
Replace.
meaning. Replace is good. We're going to do 6 of these together, then I'm going to let you do 5 on your own, and then we'll check them. Anyone still need the definition or the steps?
Yes. Wait, is this? Okay, so substitute these expressions into an equation itself. Okay. So is it doing a problem substituting and then doing a problem with the substitute?
Kind of. It depends on if we have to do step 1. Sometimes we do, sometimes we don't.
That was my last one. Not English.
Anyone else still need this or still working on this? Okay. So starting with the first example. Our first step is to solve for x or y. That's if we aren't given an equation that has y equals or x equals already. Do we have an equation that's x equals or y equals? Yes, so that means we don't have to solve for it. In this case, we have 2. That doesn't happen all the time, but it does happen. Our step 2 was to substitute that into the other. So because we have 2 of them, we can do one of the following. Either take this expression from the first equation and substitute it in for y into the second one. Or take this expression from the second equation and substitute it into this y in the first. Either or. No matter how you substitute this one, you're going to end up with something that looks like this, whether you put this on this side or this on this side. Because you basically are substituting them into each other. Now that we've done that, we can solve for x and then continue. Before we do that, the solutions we got for graphing, 1, none, infinitely many, still apply here. So without solving this, what type of solution will we have? Not one solution, because we don't have the same coefficients or the same constants. So we're going to end up with one solution, x, y, some ordered pair. Now let's actually figure out what those are. We can solve this however we want. What do we want to move first? -1, and then you can do the next one. So if we're moving -1, we're going to add 1 to the other side. Because we moved 1 to the right, we now need to move 2x to the left by subtracting. So we have 2x equals -4. Divide both sides by 2 to get x equals -2. Once you have one of your variables, then you're going to take that number and you're going to substitute it back into one of your equations to find your other variable. It does not matter which one you do. I'm going to do both to show you that they both work, but you don't need to do both. You could just pick one. So take one of these and put -2 into one of these equations. Again, it doesn't matter which one you choose because you should get the same answer either way. As we continue on, you'll see that maybe one is easier to put back in than the other. But you can do either or, it doesn't matter. Once you have your x and your y value, you can put them together in an ordered pair. So this would be the point -2, -1.
Question.
Yes.
How did you get your y?
Put the answer you got for x back into either this one or this one. Either or, doesn't matter.
-2, -1? I mean,
-2, -9. Before we move on, does anyone have any questions or confusion about anything we just did? This type of substitution is one of the more rare ones because you have y equals for both. Most of the time that doesn't happen, but occasionally it does.
hold on, check wrong.
We're going to do the same thing for 2. Do we have an equation that solves for x or y?
Yes.
Yes, the first one, so we don't have to do that. Because we have something that solved for y already, we're going to take that expression, 6x. We're going to substitute it into the other one where y is. We don't need to solve this equation for y. It doesn't need to be in slope intercept form. We are going to rewrite that second equation with this in it. So it's going to look like this. 2x plus 3. Instead of y, we're going to put 6x in parentheses. And then equals -1. When you are substituting, you should be, after you substitute, you should notice that there's only one variable left. If you substitute and you still have an x and a y, you probably put it in the wrong variable. So always double check that. So here we could multiply. This would be 2x plus 18x equals negative 20. We could combine our like terms to get 20x. Divide both sides by 20. Right?
It says 2x plus 3y. Where is y?
So because this equation equals y, you can replace or substitute 6x for y.
Okay, so that is the substitution.
Once we get our x value, you can put that back into either of these equations to find your y value, but this one would be easier since it's already solved for y. Yes. Say that again. This one was.
How do you get negative 1
This side was negative, but this side was positive. Yes, I'm not. Say that one more time.
For the y,
I heard part of that, but not all of that. Where would I put the what? Originally? In for this one. So our ordered pair would be -1, -6. Have any other questions, confusions we want to clear up? Let's try number 3. Do we have an equation that's solved for x or y? Yes, the first one. So we're going to take that expression, x plus 9. We're going to substitute it into the second one where y is. So we're going to rewrite that second equation with this expression in it. 3x plus 8 times x plus 9 equals -5. And then you're going to start solving. So this would be 3x plus 8x plus 72 equals -5. We could combine the terms. Yes.
So do we have to change the original equation to be like x equals or y equals? Because these are already giving it to us. Do we, at the end, do you put the answer back into the one we changed to the original problem?
We'll do a couple of examples, see if that answers your question. Because I'd have to see it worked out in order to answer your question right now. Okay, we could subtract 72 on both sides. And then divide both sides by 11. So x equals -7. Once you have that x value, put it back into one of these two equations, doesn't matter which one, but I'm going to use this first one since it's already solved for y. So y equals -7 plus 9, or 2. So my answer would be -7, Have any questions on number 3 before we move on to 4? For number 4, do we have an x or y solved by itself already? We don't have an x or a y. We have an x. Just because it's not a y doesn't mean we can't use it. And because it's x, we don't need to solve it for y. We can use either or. It's going to be solved kind of the same way, but a little different. Because we're still going to take this expression and substitute it into the other one, but now it has to go in for x, not y, because it's an x equals. So this would be really where you need to make sure that when you substitute, you're substituting it into the right thing, because maybe you had a lot of y equals examples, and you put this in for y instead of x, then you would still have an x and a y in your equation. And it would throw things off. So when we rewrite this second equation, it's going to look like this. 2 times 4y plus 7 minus 6y equals 12. And then we can start to solve this. Distribute the 2, so we have 8y plus 14. Bring down the negative 6y. Combine your like terms. So you have 2y plus 14 equals 12. Subtract the 14. You have 2y equals negative 2. And then divide those sides by 2. In this case, because we solved for y first instead of x, when we put the second, we're now solving for x. We're going to take this and put it back into this first equation, or you can put it into either one, it doesn't matter. So x equals 4 times negative 1 plus 7. X equals negative 4 plus 7, or x equals 3. Be careful with your ordered pair here.
Whenever, you know how like whenever we change it so that it's y equals like an x plus number, like minus number, when we do the other way around, we just subtract the y. Like when x is the first, like x equals a y. I don't know if you're
Yes, you can make x first. You can solve it for x or 1. Be careful when you write your ordered pair because we solve for x second, so this would be the point 3 negative 1, not the other way around. I mean, not the. This expression? No, this one? I'm not sure what you're talking about. This one, it should be y, not x. But here you wouldn't be able to do that because you don't have a point. You don't have slope. So no, I wouldn't do that. Other questions on 4 before we move on to 5? For number 5, do we have an equation that solves for y or x? No. So in this case, we have to solve for that first and then move forward. It doesn't matter which one you choose to solve for. You can pick any of these x's or any of these y's. I will say the easiest way to solve this is look for the variable that has a coefficient of 1 or -1. If you choose to solve anything else, you're going to end up with a bunch of fractions, which is fine. You would just need to be careful when you substitute and solve. So if you pick the one that has a coefficient of 1 or -1, that would be the easiest way to solve this. So because we're solving for y, we need to get y by itself, make it a y equation. How would we do that? Felix. Subtract 2x on both sides. I'm going to rewrite this so that the x term comes first. So we have y equals -2x minus 2. Now we have an equation where y is by itself. Now we can take that equation and substitute it, or the expression, and substitute it into the other one. The box and the arrow is not necessary. I'm just trying to show you where it goes. Yes, Lily.
Okay, so what did you do here?
Solve this equation so that it was y equals.
Okay, so you did -2 on both sides, -2.
Subtract 2x on both sides, yes. And then rearrange it. Okay, okay. Yes. Right, so this would be rewritten as 5x plus 3 times -2x minus 2 equals -8. After we rewrite this, we can start solving. 5x minus 6x minus 6 equals -8. Combine your like terms, so we have -x minus 6 equals -8. Add 6 on both sides. So we have -x equals -2. And then divide both sides by -1. So we get x equals 2. Michaela, I think this is going to answer your question. Now that we have this, you now have 3 different choices that you can put it back into. Doesn't matter which one you choose. I'm going to put it back in this one because it already has y by itself, but you can put it back into any of them. Did that answer your question? So y equals -2 times 2 minus 2. That's a lot of 2's. So y equals -4 minus 2, or y equals -6. Notice that in all of the ones we've done so far, they've been one solution. We haven't had any no solution or infinitely many. If we were to get one of those, I don't think the next one we're going to do is that either, but you wouldn't get very far. You would substitute, you would combine your like terms, and when you do that, your variables would cancel. And then you would immediately know if it's no solution or infinitely many. For number 6, I want you to walk me through how I would do this. Good, go ahead.
Start with the bottom.
Okay.
Minus 2x on both sides. And start with the equations that equals. You need to y equals -2.
Okay.
And then you will
like replace it, how would I write that?
2x minus 3 times negative 2x plus 9 whole square.
Got it. Okay, then what? You can keep going or you can hand it off to someone else. Okay, go.
Distribute the negative 2x.
Okay. And then what are those two extras? And I would give 8x, okay. And then what?
Add 27. It'll be 8x 1 equals 16. By 8 on both sides. X.
You lost me. Go back to this.
We've already added 27 to both sides.
Oh, I have to do it for both sides, okay.
Then 8x equals 16. And then you divide 8 on both sides.
Got it. Give 2. Okay, and then you can keep going or pass it off to someone else. How would we continue this?
Alright. And we go back to the base stuff for y equals negative 2x. Case the x which is
How would I write that?
to be y equals negative 2 times 2 plus 9. And then you solve this to be y equals negative 4 plus 9. And that would be y equals that would be 2 5.
Just negative
Has to be 2 and 5 plus 9.
negative 11 plus 27.
Like that?
Yes.
Anyone have any objections to any of this or have anything to add? There.
Around the 2 and 5.
Okay.
I'm just at 18 tiny bit behind.
Oh my goodness.
Anyone have questions on that one? All right. So I want you to try the next 5, 7, 8, 9, 10, 11. I'm going to check in about 10 minutes to see how everyone's doing, if everyone's finished or not. If not, I'll give you more time. If so, then we'll go over the answers. Then do you have a question for the class or one for me specifically? Bella? Alright, so you guys have the next 10 minutes, we'll check in and then we'll go from there. If you have questions about how it was solved, we can go over that in a second. I'm just going to talk through the answers first. For number 7, there would have been no solution because they would have ended up being parallel lines. Number 8, the solution was 8, negative 2. 9, the solution was infinitely many solutions. 10 was negative 2, 0. And 11 was negative 1, 5. Do we have questions on any of those? I mean, say that one more time.
Like this, right?
It's like,
So for number 8, you needed to solve one of the equations. The easiest one would have been this one where x is by itself. So subtract 4y on both sides. because this side is 0, this side would just be negative 4y. You don't need the plus 0, you could put it, but it's not necessary. Then you're going to take this and substitute it back into the second equation next to 3. Should be 3 times negative 4y. That would give you negative 12y. Combine your like terms to get negative 10y. Divide both sides by negative 10 to get negative 2. Put this back into your x equation to get positive 8. Other questions on any of these?
How do you get 4y? Minus 4y.
This one you're solving for x, so you move the y by subtracting. Any other questions? For the remainder of class, if you didn't finish these and you're just writing down the answers, definitely make sure you get that practice and do those, finish those. And then the things I said earlier, so all the Khan Academies that are due this week, the 2 on graphing, the 1 on substitution, the 2 Delta Maths, 1 that was supposed to be due today, and 1 that'll be due next class, graphing and substitution. If you finish all of those, or finish some of those, work on the others, and then you can go back to the last set of notes on systems of graphing and do the problems in there. Once you finish all of those things, then you can have time to work on other things, but we worked on those first. Anyone have any questions on what we're doing for the remainder of class? Donna.
Can you go down to 11? I just want to see the keep it where we can
Alright, you guys have this time to work. Let me know if you have any questions.